Okay, let's get started. All right, welcome to LinkedIn's stream processing meetup event. My name is Gary Yang. I'm a senior engineering manager in the stream processing group, together with F.A. Genser and David Jacola. We are co-hosting this evening's meetup event. So tonight we have 5 speakers. We have Mohit from AWS, Chamikara from Google, Alan Ryken and Jensen from LinkedIn. We'll introduce their bio in more details as we get to their talk. All right, so tonight's agenda goes like the following. We will go through some logistics first. Then after that, we will have 3 tech talks. First one will be cruise control at AWS, MSK serverless. Second one will be Apache Beam, fully language portable and scalable batch and stream data processing. And the last but not the least is effective detecting and preventing abuse on LinkedIn with Beam stream processing. So each session will be about 30-minute presentation plus 5-minute Q&A. So these talks will be recorded. Then they will be posted to LinkedIn Engineering YouTube channel, as well as the Meetup event site. If you are interested to participate in the Meetup series, please post a message to the Meetup site or contact any one of us, Adam, David, or myself. And then one last thing, if you want to ask questions, please post questions using the Q&A tool, which is the little icon over there, as you can see on the screen, not the chat tool, the Q&A tool. So at the end of each talk, the presenter will go through the questions. All right, so that is the logistics. I think I'll pass it on to F.A. to queue up the first tech talk.
Thanks, Gary. So our first speaker is Mohit Paliwal. Mohit is a software engineer at AWS Managed Streaming for Apache Kafka. He has built AWS MSK Serverless and AWS Glue Schema Registry from the ground up. He has also built real-time streaming platforms for intelligent routing for Amazon CloudFront. Without further ado, let me leave it to Mohit for his talk on cruise control at AWS MSK Serverless.
Okay, thank you, F.A., for that nice introduction. Let me begin by sharing my screen. All right. Can you see my screen?
Yes, we can see it.
Perfect. So yes, the talk today is going to be Amazon MSK serverless with cruise control. I'll start by introducing myself. My name is Mohit, and I work as a software development engineer at Amazon. My pronunciations are he and him. And I think a lot of my introduction has already been covered by F.A. So without further ado, I'll jump into agenda. Right. So what I want to cover today is Amazon MSK and Amazon MSK serverless, a brief background and history of them. With Kafka, what is the need of a balanced cluster? Then what cruise control is, our open source collaborations with cruise control maintainers. And then I'm going to talk about something very interesting, which is topic coloring and the future work, right? So let's begin. So Amazon MSK stands for Amazon Managed Streaming for Apache Kafka. Let me begin with a bit of history. Most of you would already be familiar with Kafka and would know how non-trivial it is to run Kafka in production. Our customers were already running Kafka on EC2s, and they came to us asking if we could manage it for them. So in 2018, we launched Amazon MSK as a managed offering for Kafka. With Amazon MSK, now customers could leave the heavy lifting to us and focus on their business problems. With MSK, customers get all the goodness of the best security practices. There are like network security in place, which means that customer traffic transits through AWS own network. MSK supports multiple Kafka auth mechanisms like SASL Scram, Amazon IAM, mutual TLS, and so on. The data in transit is encrypted, as well as it's encrypted at rest. We take care of security patching and maintaining your instances, as well as quickly handle any Kafka security vulnerabilities that we get to know, right? The data is also backed by AWS EBS volumes, which are scalable and durable. So we take care of the durability part. We manage any update in a rolling way so that your produce and consume performance does not get impacted. There are health monitors for your cluster that we are continuously monitoring. Any broker death or VMs were to go down, we take care of that. We take care of any disk volume replacement, and all the best practices that come with any Kafka deployment. We are also fully compatible with Apache Kafka APIs. We also do expose your cluster matrix through CloudWatch, which is a logging analytic platform from AWS. Additionally, MSK exposes Kafka GMX matrix over an HTTP port for you, so that you can build your own dashboards and build your observability story if you were to use Prometheus and Grafana with it, right? Amazon MSK is not a single service offering, right? Over the years, we have been working hard to build a whole ecosystem around it. You could run your consumers on AWS Lambda. You could establish your compatibility contract between your producers and consumers using AWS Glue Schema Registry. There's also Amazon MSK Connect that is basically Kafka Connect that with Kafka connectors can bridge data between any source and sinks. Your source could be just a plain SQL database or S3, or your sink can be something like S3 or any other sink formats available. There's a lot of other integration that we bring to the table. You can get AWS CloudTrail, CloudWatch integration by default. And you can also use CloudFormation or CDK to write your infrastructure as a code, right? What is Amazon's MSK Serverless? So early this year, we launched a new cluster type offering for MSK called Serverless. Customers wanted us to build something more hands-off for them. Customer came to us and asked us if we could handle the provisioning, scaling, cluster balancing, any version upgrades for them, right? So we went back to the drawing board, and the result was a new cluster type that was called MSK Serverless, right? What does MSK Serverless exactly do, right? MSK Serverless takes care of broker provisioning, scaling based on your workloads. Super easy to use, right? And that's one thing that we wanted to bring to the table, that to make your Kafka cluster creations or running your workloads super easy. You can get your cluster ready quickly, up and running. We handle cluster balancing for you. If your load patterns are spiky, you now don't have to create over provision Kafka clusters. Your serverless clusters can also handle bursts very easily. And interestingly, just like microservices, you can split your monolithic Kafka cluster into smaller microclusters. One of our essays have written a very nice blog about it, and I'll be happy to share it at the end of the presentation. Moving on. Why is a balanced Kafka cluster important, right? An imbalanced cluster means that some of your replicas have higher load, disk usage, or network usage. You can have a much higher replica count on one broker than another broker, right? The imbalance can result in degraded performance and unhappy producers and consumers. There could be different, traffic patterns that can lead to imbalance. Also, the virtual machines, we know that they don't live forever. This is The example on the right is very simplified example, but as you can see, broker one seems to have some high resource usage, which is making it run hot. And there are multiple tools that Kafka admins or enterprise admins use nowadays to manage their Kafka clusters. And one of such great tools is cruise control, right? So let me also talk a bit about cruise control. Some of you, it's very popular tool. Some of you would already be aware of what cruise control is. But to set the context, cruise controls began at LinkedIn and is now an open source tool. You can set up cruise control easily and it handles the imbalance on your cluster. This also makes Kafka admin's life much easier. Cruise control works on multi-objective optimization algorithm. There are some predefined goals like CPU capacity goal, network capacity goal, disk capacity goal, and so on. So now if your cluster reaches a certain threshold, like let's say 70% of disk capacity on a broker, or let's say 60% of CPU capacity on a broker, cruise control has the ability to build a plan, which includes replica movements and leader movements, and in an optimized manner, and make a cluster balanced, abiding by all the goals that you have configured, right? And this all automatically without a manual intervention. There are hard goals, which means that they must be satisfied, and there are soft goals which are best effort basis, right? Additionally, it also detects dead brokers, slow brokers, and provides you REST APIs to promote and demote brokers and things like those. Cruise control, interestingly, so one interesting part that I want to talk about is cruise control needs Kafka matrix to monitor cluster, right? And it does that to understand the load on your cluster, builds a cluster model, and provides, this is all done by providing a matrix reporter jar that you can install on your Kafka brokers. The matrix reporter jar then saves the Kafka metrics on a topic in your cluster. And once the metrics are a topic, cruise control can consume from this topic and build a load model, right? Since MSK consumers, MSK is a managed service, right? So you don't get to choose what you want to install at your on your brokers. We do that, we handle it for you. So MSK does slightly differently. We open the Kafka matrix through something called open monitoring, right? This is another way to read matrix, right? So we don't install matrix reporter jar and instead get matrix from a open monitoring directly, right? And that's what cruise control can actually work with and read an alternate way of reading matrix and still generate the proposals and work with that, right? So this is an example of how and what cruise control does, like what kind of actions does it perform. So if you would see on the right-hand side, there are two actions. The one replica, which is T1 P0 leader, is moved to a follower by a leadership move, right? There is another replica, which is completely moved along with its data to another broker, which is in orange. So there are two major kind of replica actions that any Kafka admin would perform to balance their clusters, right? And this is what cruise control also does. So that's the rebalancing, how rebalancing happens. I want to talk about some of the open source collaborations that we at Amazon MSK did with cruise control, right? So we collaborated with cruise control and added some plugins to cruise control that would make the user's life easier. One of the major things we added to cruise control in the past has been integration with Prometheus, right? Prometheus reads matrix from brokers in the cluster. So in your cluster, you can expose GMX matrix the same way as MSK would do. And on an HTTP port, then Prometheus can scrape these matrix at a regular defined interval. And cruise control would then read the matrix from Prometheus and build a load model instead of reading raw Kafka matrix from a topic which are otherwise created by a jar, right? This is something that we added a couple of years back. This year, we collaborated with maintainers of cruise control again and worked together to bring another goal to cruise control. To explain what this goal does, let me first introduce something called topic coloring. Right. So as you can see in this picture, topic coloring basically means grouping topics into a group of brokers in your cluster, right? So think of it as splitting your cluster into multiple subclusters. And let's call these subclusters a set of brokers or broker sets, right? So the motive here is to bring red topics to red brokers, blue topics to blue brokers, green topics to green brokers, right? And you would ask, why do this, right? You just have one Kafka cluster. Kafka already is fault tolerant. What's the reasoning behind this, right? You can use topic coloring to isolate your workloads, right? You can either have different type of workloads or different priority of workloads, right? So your red topics can be completely different in nature in terms of the kind of traffic that they get, or maybe they are super critical, right? So you want to separate them out. And the green topics or blue topics can have a completely different nature, right? Kafka is fault tolerant, but sometimes, broker deaths and especially gray failures on a single broker can affect Kafka clients' performance, especially produce and consume. And people who would be, managing their own clusters, Kafka admins would know this. Topic coloring can limit the impact on, only limited topics, right? On a if there was a broker that had such an issue, it would be limited to a set of topics. Not all the topics would get impacted. Yes, there is one controller in the whole Kafka cluster, but that's a different issue. You could limit inter-broker communication if your topics were all spread out in the whole cluster. So, against if your topics were spread out in the whole cluster, right? Any topic partition has replicas, and there are replication bytes going out from each broker, right? So using this, you can limit the communication that's happening. You're not communicating with all the brokers. You're communicating with a limited set of brokers in terms of replication bytes and network traffic that's going up. You can also split your heterogeneous clusters into a group of homogeneous broker sets. You can just add more brokers of a single type to a broker set if you need to scale up or scale out. And it just lets you manage your clusters better, right? So what do we do to implement topic coloring? We need to define broker to broker set ID mapping, right? Broker set is a group of brokers, part of your cluster. You also need to define topic to broker set ID mapping, like, red topic has to map to red broker set. You have to also tell that broker ID from 1 to 10 are part of my red broker set, right? So these are two mappings that you would define. And also you need to address some edge cases, right? What if you have some missing mappings, right? How do you deal with those, right? What if your topic is already not defined to map to a broker set? How do you deal with those, right? So keeping all of these things in mind, we also additionally we also need to with the pluggable nature of cruise control, we need to provide these things as pluggables so that users can write their own implementations. So as a result, what we did is we added a new goal, and the new goal is called broker set aware goal to cruise control, right? And like I said earlier, there are hard goals, there are soft goals in cruise control. And cruise control, basically, if you have configured these goals, it will optimize, it will generate a proposal of replica moments or leadership moments altogether, which abides by all the goals, right? All the hard goals. So we added this. If any user wants to use it, they can add broker set aware goal to their configuration. Replica movements. What this goal does is it limits your replica movements within a set of brokers within that defined broker set, right? So just like if you know there is a rack aware goal, which makes your replica movements within all rack aware, so that your partition is rack aware. It's distributed evenly on all the racks how you have defined it. In the same way, broker set aware goal attempts to keep all your movements within a broker set, right? And that is something that is needed for topic coloring, right? It also adds pluggable interfaces to resolve, broker to broker set mapping. You can define your own mapping, or there is a default mapper which is provided as a JSON file. That's a default implementation where you can define what your mappings are. We have also provided a pluggable interface to map topics to a broker set, right? You can write your own. It's at replica level. It's not at a topic level. So at a granular level, you can decide how your replica has to be mapped to a broker set. And the default implementation of topic to broker set mapping basically does topic name hash based mapping to a broker set and uses consistent hashing just to minimize the movements. So these are the components that we have added. One is broker set resolver. Broker set resolver is basically the part that maps your broker to a broker set, right? You provide your list of brokers against one grouped broker set and provide it an ID, and you can put it in a JSON file. Broker set assignment policy is interesting. Since you would keep adding or removing brokers from your cluster, you constantly your resolver needs to keep updating the mappings, right? There can be scenarios where you have a missing broker that cannot find a mapping, and these are the edge cases where by default implementation, what we do is any broker is by default, mapped to a modulo of the number of broker sets. And, that's it. You can, of course, write your own implementation here and solve pluggable. And then this replica to broker set mapping policy that I talked about, which works with topic name hashing. So that's the state as of now. We have topic coloring in place. We are using it at MSK Serverless to balance our clusters. But we have a lot of future work that we want to do and we want to contribute to. Broker set aware distribution goals, and distribution goals are something which are soft goals. Right now, what we have added is only a hard goal, but what we would want to do is we would want to make use of the soft goals that already exist in cruise control, which basically don't wait for you to reach the threshold of a broker capacity to breach, let's say CPU utilization. It doesn't wait for it to reach at that level. It tries to keep it evenly distributed on best effort basis, right? So we want to introduce that at a broker set level so that all the brokers within a broker set are evenly distributed and are not waiting for you to reach at a threshold. We also want to integrate it with a provisioner, right? So that users, if they want to scale a broker set individually, they should be able to do it. You can have a broker set that requires scaling. You can have a broker set in your cluster that's actually doing fine, right? So you'd want to add more brokers to your broker set that requires scaling, and that's something that we want to contribute in future. We also want to trigger a balancing by an API by a broker set ID parameter, and this is just an API thing that a Kafka admin can basically pass a broker set ID and say, hey, I want to balance only this broker set, right? Also, I think this part is already done. If I'm not wrong, we already have stats populating. So I think that's not future work. Takeaways, right? Leverage automatic balancing tools like cruise control for smooth operations of your Kafka clusters. Administration of Kafka, like I said multiple times, can get hard. It's not trivial, and these tools will make your operations, make your SRE's life much easier. If you're using MSK Serverless, AWS will handle the cluster balancing for you. Go try it out. Also try out topic coloring and see if your use case fits. Right, it's already available. You can take the latest cruise control from GitHub, and you should be good to go. You just need to add broker set aware goal to your configurations. It's not added by default for the reason that not everybody wants to utilize topic coloring, right? So yeah, that's all. Thank you so much for patiently listening to me. And if you have any questions, yeah, let me know.
Great. Thanks for the great presentation, Mohit. So there are some questions in the Q&A, and I will maybe read them aloud. So the first question with the most upvotes is, how do you handle one partition very hot on broker? It requires producer side changes, correct?
So the question is, how do we handle one partition that is hot on one broker?
Yeah, I guess, how do you handle one partition very hot on broker? Does it require producer side changes, or do you do something else?
It doesn't, we don't control producer side changes, right? Because, as a service, our clients are free to do whatever they want. Let's say a partition is hot on a broker, right? And by that, what I mean is, you would definitely have replicas, right? And our replicas, the way we have follow replicas, they are on a different broker in a different rack, which we call AZ. And we maintain a good replication factor so that if a broker was running hot with a single partition, we would, cruise control would basically move it to another broker. And if it is just one partition, I think I'm just trying to understand the question also correctly. If there's one huge partition that's causing this, I haven't seen such cases where one single partition has caused it, but we also try to limit the size of one partition and provide that recommendation to customers that do not create huge partitions, like split your topic into multiple partitions.
Great. The next question is, what is the largest cluster size you have used with cruise control to do the rebalancing without seeing any issues?
So the largest cluster size, I think I'm not the right person to talk about this, but I can provide you references what the exact number is. I have done different testings on different size of clusters, which vary in size, with tens of brokers, with hundreds of brokers, and we have got satisfactory results.
Right. Next question is, when broker is really down, offline, how do you ensure the producer is non-blocking behavior while the broker is being offline for movement of rebalancing? Do you get duplicated messages while doing rebalancing?
We don't. That's a very interesting question. So the way when a broker goes offline, and this is a feature that's available in MSK provision as well, right? We call MSK provision. That's a service that we launched. That's a cluster type that I talked about initially in the beginning, where we manage if there was a problem with a broker and it went down, we manage the workflow that replaces it completely. During the time, and if I understand the question correctly, during the time, if a broker is going down and a rebalancing is going on, if that is what you mean, cruise control handles it elegantly, and we have seen these cases. Cruise control also has ways to move offline replicas. But since there are things like we don't use provisioner really. Provisioner is a component of cruise control. We have our own mechanisms to replace these nodes. So we're able to get around that. We haven't seen any issues. But I can provide you more details and try to understand your question deeper.
Great. Next question is, what does MSK offer that Confluent does not? It's like a comparison question, I guess. It's a more broad question.
Right. I'm not the right person to answer that. I think I'll refer you to my product manager who can provide you more insights on the comparisons, and I'll be happy to share those comparisons with you. Yeah.
Mm-hmm. Next question is, can you increase the number of broker? By the way, I forgot mentioning the names of the people who asked the question. This is from Yang. Can you increase the number of broker set? How to avoid hot broker set that contains high throughput? Right.
Very good question. So yes, you can increase the number of broker sets. You can basically, your broker set resolver can now say, hey, I used to have 3 broker sets. Now I have 4 broker sets, right? Or n+1, n+2. And broker set aware goal will now trust this mapping, and based on this new mapping, generate proposals. So you can increase that. The default implementation is by a JSON file. That can be a little tricky, but you can always update it, your JSON file once you have increased the broker set size, and restart your cruise control, and that should work. Second question is how to avoid hot broker set that contains high throughput. Yeah, there are multiple ways of doing this. The approach that we would recommend is think of broker set as a whole, and if the broker set is running hot, cruise control does provide you recommendations like provision recommendations, which you can integrate with provisioner, or you can basically take your own decisions to scale up or scale out your broker set, and you can do that on your broker set completely if it is running hot, and if cruise control cannot move replicas and finds it too hot. Yeah.
Mm-hmm. Great. Next question is from Ogden. Does MSK Serverless allow clients to access the Kafka admin UI? For instance, can you track the current lag between your consumers and the end of the topic?
We don't allow, I think your question is, do you allow clients to access the Kafka admin UI? No, not right now, because we want to abstract everything and keep that pain away from customers. That's the idea. And we do publish some of these metrics like max consumer offset lag, so that customers have visibility on that. But if there was something like this to happen, we would on the back end or as service owners try to fix it. But we do expose these metrics as a observability thing to our customers.
Great. Next question is from Dakshin Rajavel. In which version of Kafka you provide cruise control? Do you provide cruise control on versions of Kafka that doesn't have Zookeeper?
Do you want to take that, FA?
Yes. So cruise control supports Zookeeperless. It runs with Zookeeperless Kafka. It doesn't have any Zookeeper dependency. So if in case you're running your Kafka with craft mode, cruise control can run on that.
Thanks for that. Yeah.
Next question is from Mark Jackson. How would you scale a topic partitions when you have assigned messages to a partition by key?
Could you please repeat that?
Sure. So how would you scale a topic partition? I guess this is how would you increase the partition count of a given topic when you have keyed messages. You have messages that go to a specific partition.
I think you can always increase the number of partitions by running alter APIs to your Kafka topic. But I think your situation, what you're trying to say is when your messages are keyed, right? I'm not too sure during that situation, does it result in any issues if you were to run, an alter API? But alter API is, Kafka API is always there where you can, increase the number of partitions. And that, in my opinion, should work fine. But I'm happy to discuss more on this case. Yeah.
I guess the concern here is if you increase the partition count and if the messages always go to specific partition IDs, the new partitions may remain empty. So I guess that also requires maybe some changes in the keying to ensure that the new partitions also exist. Right?
I see. Yeah, bang on, right? So yes, you'll have to change your keying strategy, to balance them evenly. But if they are not balanced, right? If you increase the number of partitions, and if you are for some reason producing more to these older partitions, and if there was an imbalance as a result of that, cruise control will still handle that, right? Will still move things around. So yeah.
So next question is from Greg Roloffs. Create topic is a Kafka API. Were there Kafka changes as well to limit topic creation to a single broker set? Or does the new CC goal auto-heal topics that violate the mapping?
So new CC goal, you can you can add it, and what it will do initially is it will do a lot of movements initially in the first run, because now you want to make it broker set aware, right? So in that case, once cruise control runs on your existing cluster, it will make it broker set aware, right? Where it will group your topics together. And after that, even if your create topic is actually creating, creating topic to multiple brokers, cruise control's broker set aware goal will kick in immediately, and move these replicas around just to group them and bring them to the right place.
So there's one last question from Stanislav Pak. Does MSK support tiered storage, which means all segments on blob store with ability to read?
Right. We don't as of now, but stay tuned. Something interesting is coming. So if you're expecting tiered storage, expect if your announcement, and you'll see things play out in next quarter or next couple of quarters. Yeah.
Great. So that was all the questions. Thanks, Mohit. And with that, I will pass it to Gary for the next talk.
Thank you.
Thank you, FA. Thank you, Mohit. All right, we're right on time. Awesome. All right, next up, I'm very glad to have Shamikara from Google to talk about Apache Beam, which is a fully language portable and scalable batch and streaming data processing framework. Shamikara is a senior software engineer at Google and a PMC member for the Apache Beam project. He has also been contributing to Apache Beam from its inception and has primarily contributed to various Beam IO connector frameworks and Apache Beam's multi-language pipeline framework. Before Google, Shamikara completed his PhD at Purdue University with a focus on large-scale distributed data processing. So welcome. All right, pass it on to you.
Thank you very much. Let me share my screen. All right. Okay. All right. So thanks for the introduction. My name is Shamikara Jalat. So I'm a software engineer for Google. I've been here for about 8 years now. And I've been, we've been with the Apache Beam project. We started the project around 2016, so it's been around 6 years now. So I'll be talking about Apache Beam and how it supports batch and streaming data processing, and what is its portability framework and how it helps. All right, so let's talk a little bit about the history first. This the whole ecosystem, related to MapReduce started around 2004 when this MapReduce paper from Google came. MapReduce as a concept has been around, for a long time in functional programming, but in 2004 there was this paper where they introduced the concept for distributed programming, where you can simplify your computations to mappers and reducers, and massively parallelize this to process a large amount of data. So from there on, within Google, we had a whole bunch of applications built on top of this. So we had a number of storage systems like Spanner, Colossus, Bigtable, etc., as well as a number of data processing systems like Flume and Millville for batch and streaming data processing. And around 2014, Google came up with a product called Google Cloud Dataflow, which basically tried to combine some of these internal products and make a cloud offering, which is a fully managed service for batch and streaming data processing. So meanwhile, in the open source world, in Apache Software Foundation, we had Apache Hadoop project, which I'm sure many of you are familiar with. And there was this whole ecosystem built around Hadoop, bunch of systems like Pig, Hive, etc. And then there were other Apache projects like Apache Spark, Apache Flink, etc. We had this whole open source ecosystem. So around 2016, we came up with the Apache Beam project. The idea was to get these great ideas, both from internal Google as well as the open source world, and come up with the data processing system that is fully open source and that can support both batch and streaming data processing. And this was contributed to by Google as well as a number of other companies. And we became an Apache top-level project around 2016. Okay, so that's the history. So what does Apache Beam provide? Main thing it provides is it gives you a unified programming model for batch as well as streaming data processing. So you don't have to go from a batch application to a streaming application. You don't have to rewrite your your application to go from batch mode to streaming mode. It should be possible to seamlessly move from a batch application to a streaming and vice versa. Also, Beam provides support for multiple runners, so you won't be stuck to a single runner. You won't be locked in. You can easily switch between runners and keep your same application, keep your same program, but you can switch the runner. Also, Beam has support for multiple language SDKs. So again, you're not stuck to a single language. Beam supports a number of languages, so you can use one of those languages to write your program, that your distributed data processing program. So also Beam came up with something called portability framework. The idea was that we have this set of runners that Beam supports, as well as set of SDKs, and we wanted to simplify this ecosystem. So we came up with the portability framework, and this also allowed us to provide some cool features, which I'll talk about in a little bit. Okay, so just to give some concepts, let's look at the structure of a Beam pipeline. So a Beam pipeline is basically a DAG, a directly acyclic graph of P collections and P transforms. P collections represent data. So this data will usually not be in your machine. It'll, it basically represents some data set that lives somewhere. And P transforms represent computations that you perform on these P collections. Now, this gives the structure of the basic word count application. So you will start with, for example, a P collection of file paths, and you can apply a read P transform to come up with a P collection of lines. You can split those lines to come up with a P collection of words, right? And then you can turn them into KVs using another P transform. And then you can add another one, to combine these into sums, etc. And you can format them and write these output to different storage systems. One key thing to note here is that, each of these transforms, they doesn't necessarily have to have one input and one output. Each transform, depending on its nature, could take more than one input and also could produce more than one output. Okay. So I mentioned that Beam provides a unified programming model. So what do I mean by that? So this means that Beam has the full spectrum. So you can start with, for example, a classic batch application. This is where you have your full data set at hand, and you also have your the program or the steps you want to execute on this data, right? That would be your batch application. Or it could be that you still have your data set, but you have timestamped data, and you want to split this into windows and compute each window separately. If you want to do that, you can do that as well. Or it could be that you don't have your full data set at hand. You might have some of your data, but the rest of the data might be streamed to you. This could be, for example, through a Kafka stream. In this case, you can slightly change your application to be a streaming application, where you process windows over time. Or it could be that you have your streaming application, but you also want to do some advanced features, like you want to handle late data. If you want to do that, yeah, Beam also provides features like these additional advanced features that you can add over time as needed. Okay, so let's look at some simple programs to hopefully clarify this a little bit more. So here I've given like the basic, most basic batch application that you can perform. So in this case, I have a P collection called input, and this input basically has a set of KVs where each key is a string and value is an integer, and you apply this sum integers per key computation on your input P collection, right? And the result is another P collection, which another set of KVs, where key is the string, but the value here would be the sum for each key, right? And this is applied on the whole data set. Now, if you want to slightly change this to a windowed batch application, you don't have to change a lot. All you have to do is to add this extra P transform called window.into, and as a parameter of this, you give the window type. So the type of window here is fixed windows of 2 minutes, and once this is provided, we would window data based on the timestamps of the elements, and then it would produce a result for each window instead of producing a single result for each key. Now, how can you move from the windowed batch to a streaming solution? Now, the key difference here is that you don't have all your data when you start processing. So basically, what you have to tell the system is to when to trigger, right? The system already knows that it has to process data in Windows, but you have to tell it when it should close Windows, when it should assume that data for a given window has arrived, and it can fire those results. This is done by providing a trigger. So the trigger I provided here is the @watermark trigger. This is also the default trigger for Beam. So watermark is basically a threshold that says, when all data belonging to a window has arrived. This is something that's maintained by the system based on, information from the source. And it's basically heuristic. And the system would use this heuristic to determine when a window should be closed, and it'll fire the output of that window. Right. And from there, you can go to an even more advanced streaming solution where, now on top of that, I've added a few more things here. Now you have your windows and you trigger at the watermark. It could be that, you don't want to wait till the end of the window. Your downstream steps might want to look at some early results. In that case, you can add this with early firing option, which says here, with early firings for each 1 minute. So instead of firing at the end of the window, now the step will also fire every 1 minute. And when the end of the window is reached, it'll fire that as well. I also added with late firing option. So as I mentioned, the window closing is based on a heuristic, which is a watermark. But that doesn't guarantee that you will not get any data after the window closes, right? It could be that you close a certain window and start closing another window, but you get some data that was supposed to go in the previous window, but late. So with late firing option tells what to do with such data. And here we say, whenever you get a late data, fire it. For every element, fire it. Right. The last option I provided here is accumulating fired panes. So that basically tells the system, now I mentioned that you fire every minute and you fire at the watermark, right? And also you fire late data. So how should these results be accumulated? When you say accumulating fired panes, that means that the system should keep track of previous triggers for the same window and fire the aggregated result. So if it fired at the first minute, it will fire all the data for the first minute. At the second minute, it will fire data for the whole 2 minutes, right? Likewise, it will keep firing the full data set. The other option here would be to discard the previous trigger and only fire the diff between the two triggers. Okay, so I hope that gave you some idea of what you can do with the Beam model and how you can go from a classic batch application to a full streaming solution by modifying your program a little bit. So another thing Beam provides is support for multiple runners. So this basically means that you don't have to be locked into one runner. You can choose your runner. You can move from one runner to another without changing your program, keeping the same distributor. You're keeping the same pipeline. You might want to run your application locally. If you want to do that, you can choose something like Beam's Direct Runner, which is an in-house runner for running things locally, or you can maybe run Flink in the local single machine mode. If you want to run in a cluster, you could start a Flink cluster or Spark cluster and use Beam Spark Runner or Flink Runner to run your application. Or it could be that you actually want to run your application in a fully managed service. And if this is the case, Google Cloud Dataflow might be a good option, and we have Dataflow Runner for that. So the idea is that you don't have to be stuck to any one of these. You can go from one to the other at any stage. All right. So in addition to support for multiple SDKs, Beam also, in addition to support for multiple runners, Beam also provides support for multiple SDKs. So our most advanced and most feature-rich SDK would be the Java SDK, which also has been around the longest. And I would say the second most advanced today is Python SDK, which is pretty close to Java. I think it supports the full batch and streaming feature set and also has a number of large features, a lot of IO connectors as well. And the most recent SDK is the Go SDK, which went GA just this year. It also has support for batch and streaming, but you might not find all the features that are available with Java and Python today. There's also other SDKs in development. I think the most promising would be the TypeScript SDK. This is not available for use yet, but might be available in the future. All right. Now, so as I mentioned, we have a number of SDKs in Beam. We have Java, Python, Go, and we may add more. And we also have a number of runners. We have Dataflow, Flink, Spark, and we might add more runners in the future, right? So what this means that each runner has to have some components that are for specifically supporting this SDK. So Dataflow need to have a Dataflow Java runner to properly support Java SDK. It also has to have a Python runner to support Python SDK. And we need a Dataflow Go runner to support Go SDK, right? Similarly, Flink needs to maintain multiple runners, one for each SDK. Spark needs to again maintain multiple runners for each SDK. And whenever we add another, a new SDK, we had to go and modify all our existing runners to support this new SDK, right? And if we add a new runner, again, this has to, be modified for each new SDK. So you can see how this gets quite complex. It's hard to maintain this ecosystem. So we wanted to simplify this whole thing. And the solution we came up with is called Beam Portability Framework. So this basically brings down this quadratic ecosystem to a linear ecosystem. So with portability, we have a single Dataflow portable runner that can support Java SDK, Python SDK, and Go SDK. And it's also guaranteed to support any future SDK. Similarly, Flink portable runner, there's just one. It can support all SDKs we have today, and it also is guaranteed to support any future SDK. If we add a new runner, we can add it in a way such that it supports all the SDKs today, as well as any future SDKs. So this makes the whole ecosystem much simpler to manage and develop. All right, let's look at how the Beam portability framework works. So there are two sides to this. There's the job submission side, and there's the job execution side. Let's look at the job submission side first. So you start with your Beam SDK, where you write your pipeline. And what you do is this pipeline is converted to a SDK and runner agnostic standard definition, which is a product-based definition using API called the Beam Runner API. And we also have a standard service called the job service that can accept such standard pipelines, and each portable runner has to implement this job service, right? So that's the job submission side. Okay, so before talking about the execution side, let's talk about this concept called Beam environments. So Beam has this notion of environments, which are used to execute Beam UDFs. Beam UDFs include Beam do functions. So do functions is the way in Beam where you write your business logic, right? These are arbitrary computations that are applied per element to a P collection. There are also other types of UDFs. For example, we have combine functions, which are basically combiners that tells how to take a bunch of elements in a P collection and reduce it to a smaller set of elements. So these environments are chosen by the Beam runners. So not all runners support all environments. The runners exactly know which environments they support. They're also well defined in the Beam Runner API protocol. So if you take the standard job definition, each transform there will tell which environment it needs to execute. So the most generic type of environment is the Docker environment that is supported by pretty much all portable Beam runners. This basically contains a Docker container that has the SDK in it. And the environment options here would simply be a Docker container URL. An environment can also be a native process that can execute user code. In this case, the options would be, for example, a shell to execute and maybe the program to, run your UDF in. Right. So now let's look at the job execution side of the Beam portability framework. So I mentioned earlier that, in job submission, we generate the standard definition and submit it to the runner. So once the runner get this standard job definition, it usually optimizes it to make the execution more efficient. For example, it might take some of your steps and create few steps to simplify the execution. And then what the runner would do is it'll identify a set of bundles to be executed using Beam environments. Each bundle consists of some of your data and some of your steps. This data can be, for example, your input data, or it could be some intermediate data, right? And the steps will include some of your steps that has to be executed on this data. Now, once the runner, split your pipeline into a bunch of bundles, what it does next is it starts up the environments that are needed to execute these bundles. After that, the runner would execute these bundles in these environments. Now, to do this in a standard way, Beam Portability Framework introduced another API. This is called the FN API or the Fun API, and as well as another standard service called the Fun API service. So with this API, Beam SDKs can talk to Beam runners at the execution side, again, in a standard way, right? And the SDK environment would basically receive SDK bundles from the runner to execute. Now, usually you don't just have one worker, runners usually maintain a pool of workers. So in this case, what would happen is within each worker, you would find a runner component that offers the Fun API service, as well as environments that where you can execute your Beam UDFs in, right? And each of these workers would get a part of your work, and it'll execute this work. And the runner would send to the environment things like SDK bundles it received and the data you have to use to execute these bundles. And the environment would send back the results after executing the bundle, logs, metrics, things like that. Okay, so that's the basic idea of portability framework and how we simplified our ecosystem. Now, once we built all that, we had some key insights that allowed us to do more things. One of the things we noted was that we have this SDK agnostic pipeline definition. But the thing is, it doesn't have to refer to just one environment. It could refer to more than one environment, right? So there's no restriction in the number of environments. So you could have, within the same pipeline definition, you could have transforms that refer to different environments. Also, in the execution side, the Fun API-based pipeline execution is not limited to one environment. It could start up multiple environments in the same worker. Now, the deduction we came up from these two insights is that a Beam portable runner can actually execute pipelines with transforms from multiple language SDKs. So the same pipeline can have Java parts and Python parts. These are called multi-language pipelines. So how do multi-language pipelines work? So this is like an extended version of what I mentioned earlier. So in the job definition side, you use multiple SDKs to define your job. So you have, for example, Python SDK talking to Java SDK to create your complete job. And you would then use the run app, and it creates the standard job definition, and it'll be submitted to the runner using the run API. And in the execution side, every worker, we would start up all the environments that we need to execute the pipeline. So in this case, in each worker, you will have a Python environment running as well as Java environment running. All the runner has to do is to figure out, which bundles have to go to Python's environment and which bundles have to go to Java environment, and connect these correctly. And then you can execute your pipeline, that has support for both these languages. All right. So what are the benefits of multi-language pipelines? So there are two key benefits. The first one is that it significantly reduces the cost of development. So it used to be that we had some very complex transforms in Beam that are implemented in different SDKs. Basically the same functionality, but in different languages. With multi-language pipelines, you don't have to do that anymore. You can just develop it in your favorite language, SDK, and you can afford to pipelines develop in all the SDKs. Similarly, it significantly reduces our maintenance overhead, right? So instead of having to maintain multiple copies of the same functionality in different languages, you just have to maintain one copy, and that's available to all SDKs. All right, so that's the end of my presentation. I hope it gave you an idea of the Beam portability framework and its usage. And I provided links here for further reference. Thank you very much.
Thank you. Thank you for that awesome presentation. So we have a few questions from the audience. Let me just go through them real quick. So first question from Ray Turari. For Beam, is there a plan to support a data frame-like API?
So Beam has support for data frames in Python. So Beam, so it's already available. So you can go and check the Beam data frame API, and you can use it from Python, and using multi-language, you can also use it from Java. So it should be available.
Cool. Awesome. All right, next one. So this one, let me read it through. So as you mentioned today, messages can be dropped if they arrive outside of the given process window. So let's say if the message is stuck in a, say, Kafka, a message platform for multiple hours before being processed, if the Beam window, it's say in this case, draws a cut line every 15 minutes, what happens to messages which were stuck in the messaging platform for hours? Does the delay message just get dropped?
So it's up to that system, right? So Beam just process data according to the properties you gave. So you'll tell it, when to process windows. You'll also give it, like it'll tell what to do with late data, right? So if the system can hold onto that data, Beam will get to it. But depending on your configuration of the, say, Kafka cluster, it's possible that, if there's a significant amount of delay, those messages could get dropped at the Kafka. So if that is the case, you might want to, for example, increase the number of workers you have to process this backlog faster.
If I understand the question, maybe is Beam processing data in event time or in processing time?
You can do both. So by default, it processes data in event time.
Okay.
And you can configure to use processing time as well.
Okay, so if it's in event time, if the data is still, that piece of event is still in the messaging platform, it would just be processed.
Right. So the window will be based on the timestamp you provided elements, and in the source will depending on the source. For example, if it is Kafka, it'll based on you can assign the timestamp to those elements, and windowing will be based on that.
Cool. Thank you. All right. So next question from Bing Feng Xia. This might be a broad question. What does fully managed mean to pipeline owners for their Beam pipelines running on GCP Dataflow Runner?
Yeah, so it basically means that you don't have to manage your cluster. So if you submit a pipeline to Dataflow will, you just have to give the machine type, and for example, whether you want auto scaling or not. Dataflow will make sure it'll start up a cluster and execute your pipeline. It'll scale it up or down. It'll split it. Make sure it does handle stragglers, etc. But it's a feature of Dataflow, not necessarily Beam. So if you submit to a runner that like Dataflow runner, you will get those features as well.
Okay. All right. So next one up. Yeah, so I'm sorting it by upvotes now. Apologize for not doing that earlier. So this one is from Ogden. Are there features in Runner like Spark or Flink that cannot be done in Beam? Are there instances where deploying directly using the Runner's API instead of Beam is more performant?
But I don't have a direct comparison of this. I mean, so I don't have like exact comments on this. It could be, I guess, but I don't have benchmarks to that comparison. But what Beam does is basically, you write a Beam pipeline, using the Beam's API, and the execution happens in the runner. So I would imagine it's comparable, but I don't have exact benchmarks.
Okay. Thank you. Next one, it's from Daniel. Can you talk briefly about performance between portable mode and classic mode? What measures have been taken to close the gap?
Yeah, so this is something that is runner specific. So I can talk to Dataflow. So there was a gap in performance when we initially came up with the portability layer, because again, you have this little bit more complex than, Python. Instead of Python executing like a single Python binary, now you have these two things running that has to talk to each other using gRPC. So there was some perf gap, but I think we've come very close. Now it's quite comparable. It's like for Dataflow, it's very close. I think we are, we're trying to migrate all our pipelines.
Cool. All right, so we're about time for the next talk. So I think thank you again, Shamikara. You can, if you can, please answer the questions in the Q&A tool.
Thank you.
All right, thank you. Thank you for the nice talk. All right, passing off to you, DJ.
Thanks, Gary, and thanks, Shamikara, for that talk. I'd like to introduce 3 presenters from LinkedIn. They're going to give you a talk about effectively detecting and preventing abuse on LinkedIn with Beam streaming. First off, Alan Shin is a senior software engineer who's been working on our anti-abuse infrastructure team since February 2020, focusing on anti-abuse, anti-scraping, automated activities. Next, Riken Shah is also on the anti-abuse team, working on infrastructure team using Samza Beam, and again, working on anti-abuse automation. And Xixing Xiao is also going to present to us, also a senior software engineer here on LinkedIn on the anti-abuse team. He's been working on our nearline processing platform. So let me turn it over to our 3 LinkedIn presenters.
Oh, thank you, DJ. Let me share my screen. And yeah, thanks everyone. Good evening. And this is Alan from Anti-Abuse Trust Engineering. It is a great honor for me and Riken Zhisheng to present how did we detect and prevent abuse with Beam streaming processing. Today's agenda, first of all, we will give you a high-level review of how important data is for the anti-abuse. Then we will introduce problems we are trying to solve, which is the scraping defense and AI models in the nearline mode. and then we will introduce Cronus, the underlying platform built based on the Samza Beam to support the above two use cases and also other use cases. So to begin with, I would like to quote a sentence from our former CEO, Jeff Weiner. You have to maintain a culture of transformation and stay true to your values. So what are our values? So we put members first, and we trust and care about each other, and we are open, honest, and constructive. So these values lead us to develop and build a sophisticated service to protect LinkedIn members and the customers' data. And that's why we have anti-abuse and the trust. So I want to give a high-level point of view of how we use anti-abuse data. So first, we build a bunch of metrics as the source of truth to reflect what is the real situation on LinkedIn and how's our defense going on. And secondly, is we use the anti-abuse data as the training set for a bunch of AI models focusing on different domains such as scraping and fake accounts. Third is we use the anti-abuse data as the features of the real-time defense to help us determine if this request is good or not. So I would like to introduce an interesting problem here. Every day, we received over 900 million guest requests on LinkedIn that trying to access LinkedIn members' profile. We had an offline job to distinguish this huge amount of requests to tell us where they are coming from. So if they are good bot or a bad bot or real person. So with this offline job, we know the distribution of the traffic. Basically, there are 10% of requests are legitimate users, and 50% of them are good bots, such as Google bot and Bing bot, and the rest of them, almost 75% of guest requests we received that are trying to access LinkedIn members' profile are bad actors. So what's the problem here of this offline job? So first is it's low speed. So this offline job collects the whole day's data and needs a bunch of hours to execute and complete the analysis. That basically means we can only know what exactly happened on yesterday. And secondly, it's because of the with the time going on, we have more and more technologies that could help us to get more features on the abuse defense. And with the integration and onboarding of these technologies, it also requires us to update the logic of this offline job to reflect the real situation with the latest features and data. So it has limited flexibility to allow us on this job to update the business logic and refactoring. So thirdly is we have seen if in some weeks the data in metrics job is missed 1 day or 2 days data for a bunch of reasons, and team had hard time debugging and figure out where is the problem, and overall it's hard for us to maintain it in a good shape. So that's why Samza Beam came to the picture. Why we choose Samza Beam? Because of a few advantages it has, high performance with low latencies and high throughput, and powerful APIs. With rich APIs, we are able to build up our applications with customized logic, and then pluggable architecture with the integrations with Kafka and the Kiwi stores. So with these advantages, we are able to move this labeling logic from offline to nearline. And as you can see that we have a bunch of like Kafka events as the input for our job, and we have a bunch of actions on Cronus, such as filtering, partitioning, draining, and or like after these like actions, we are able to produce the label in a nearline mode. So we will introduce Cronus more with technical details later. And as you can see, we with this like project completion, we are like, able to like improve the label production time from 1 day to 5 minutes. So this improvement is revolutionary, and it also gives us like phenomenal results. So because of that, we are able to like achieve 30% additional cash online on the bad actors. Because usually the scraping attacks like happens for a short period of time, such as a few hours. And previously we only able to know, like we only need to we have to wait for 1 day to know what exactly happened. Like that usually means the scraping attack is already gone. Now we are able to detect it within 5 minutes, and because of this phenomenal change, we are able to detect the dynamic and like distributed attacking in a fairly quick time. So we are able to achieve these great gains. And now with that, I would like to hand over to my teammate Ricky to talk about another use case.
Thank you, Alan. I'd like to go over a similar use case where we want to strengthen our defenses using a nearline framework. So as Alan mentioned about a use case where we want to reduce the processing time from many hours to few minutes, so that we can react quickly to the attacks that are happening in real time. So one other use case that we are focusing on is using AI models. We have all this abuse data that we gather, all the signals that we gather, and we want to enforce some friction in the case that we find that the user is abusive. For instance, we can detect the patterns in the abusive users by looking at their activities, which tend to be similar because of the kind of automation that they do. So we achieve that by training AI models on the offline data. Currently, all the models will also run in an offline fashion where the analysis will be done after a few hours, and we will generate the results and catch the bad actors with many hours of latency. If we are able to move this whole process to an airline fashion, where we can run these models using Samza Beam APIs, and we can use the data that we have aggregated, and we can catch these bad actors, that can eventually help improve our defenses a lot. So why Samza Beam, first of all? As in the previous talk as well, we talked a lot about the capabilities of Samza Beam, the ease of modeling, ease of using the features that are in the streaming world, for instance, windowing or aggregation or filtering. So we would like to use these features in the AI models that we want to run ultimately. For instance, one example of AI model that we would use is a registration-based model. So we know that all the abusive accounts or fake accounts, once they register, they tend to do similar kind of activity, either send a lot of requests or so on and so forth. We can detect the signals based on the historical data. So we train our model based of that on this data, and we can see that after the registration, if we look at X amount of events, we can analyze that events using our AI model and detect whether a particular user is abusive or not with very high accuracy. So for that, we'll need to aggregate such data in particular time windows. And for that, Beam is a perfect platform for us to give these capabilities and do this type of aggregations. Once the features are retrieved, we use in-house library for scoring. Scoring is nothing but a process that we use for executing these AI models on the input data. and producing a score which represents either the input detects signals of abuse or not. After the scoring happens, we can take member actions, which make sure that we are able to restrict these members in real time. And in the two models that we have onboarded till now, we have seen huge amount of improvement on two fronts, one on the fake accounts and one on the scraping activities. About 21% improvement in the fake account detection and around 15% improvement in the reducing of the scraping activities. And this not only serves as a current framework, but we are also extending this for future models which require such similar capabilities, so that we can more strengthen the defenses of our ecosystems. I'd like to pass over to Zisheng now, so we can understand more about how these use cases are using the underlying platform that is based on the SAMZA Beam, and what are the additional capabilities of this framework that we have developed.
Thanks, Ricken. Yeah. So hi guys. I'm Zhisheng. So yeah, it's so here I will present our time series the near-line processing platform, Kronos. So just two use cases I mentioned about Alan and Ricken. They both build on Kronos. So also, Alan and Ricken have been talked quite a bit about why we chose SAMZA and Beam. So I also accept that. I also want to mention that actually our original motivation to build Kronos is like to solve the out of order issues for Kafka events. So and the inter-arrival time is actually the really important basis for many metrics to relied on by AI teams. So we need to get a accurate inter-arrival time for many cases. So and this is naturally supported by SAMZA's built-in features. So that's actually one of the our original motivation. So but here I will go to introduction to more about introduce about Kronos, and how Kronos is built, and what the functionalities, and also what have been how we can use Kronos. So let's take a look. Could we go to the next slide? Yeah, so here's a high-level architecture diagram about Kronos. So as you can see, so Kronos consists of two Beam jobs. So one is called a field job. The other one is a model job. So I will go to talk a little bit more about a field job and what the field job is does. So Alan, can we go to the next slide? Yeah, so this so high level is pretty simple. The field job responsible for consume a couple of events and performing some actions, and then a event will be emitted from this job. And let's go a little deep about what exactly happens in field job. So next slide. Yeah. So for field job, there are two, as you guys can see, right? So field job is like we have a couple of steps. Each step is like a PT transfer operation. So so each step will take a PC connection, and the output is also a PC connection. So in the field job is like you can see, it will take consume a bunch of events, and then we will the next step will be used to extract required fields from that events. And then if it depends on different user cases, maybe some of the user cases require some aggregation operation and also some filtering operation. So this will happen in the next two steps. And eventually, I mean, the ultimate output for this job will be Kafka events message will emitted from this job. And Alan, could we go to the next one? And then for the model job, we'll consume these events. And so in the model job, actually, the logic could be a little bit more rich. So it means like, I mean, for different user cases, I mean, once we have different user cases, I mean, the requirement could be different. So some use cases, maybe they need to do some vendoring here. And also some use cases, maybe we need to, to do a scholar trick. And also some we need to do a model training. So it all depends. So it means like, for each user cases, we don't need to, not every step is required. So it depends on the user case. So yeah, once maybe, still a little bit confused, how each user case is separated from another one and how we, differential one user case from another one. So yeah, and then we can go to the next slide. Yeah, so here is I want to talk a little bit more how, each user case looks like in Cronus, and also how one user case, is separate from the other one. So before we talk about that, we need to understand some terms, used in Cronus. So we have 3 levels of units. So one is like is user case. So user case is and each user case have multiple process, and each process could have multiple large flows. And the flow is the fundamental unit of data processing tasks. So as you can see, right? So like the user case, the Alan talked about, the nearline labeling. That use case have 8 to 9 processes, and each process have multiple flows. So that's kind of a big user case. For some user case, they may only have like 2 processes and also like less flows. So yeah, so this is the underneath, how each user case looks like and how exactly we structure the other user cases and processes. So I don't we can go to the next one. Yeah, because of this the design, so it makes the onboarding is really straightforward. So all the onboarding is done through configs. So as you can see here, if we want to add a process, what we need to do is like we need to just need to specify what events is consumed by this process, and also have some unique name, and also we need to define the output. So how we want to different kinds of we support different kinds of output, and also we also support like process level plugins. So we have different plugins like we have filtering plugins and also even aggregation plugins. So, and also those plugins could be shared by different processes. So, and also, yeah, could we go to the next slide? Yeah, this is also a sample code about, how we define plugin. It's pretty straightforward. And also for each plugin, we have ID, and if one process want to use this, plugin, we just need to add this, we just need to add this plugin ID to the process definition. Yeah, and let's go to next. Yeah, and also for the output. So each process we can have multiple outputs. Each output we have a flow ID to specify that. So because let's say for example, if we different processes that consume the same events, so we don't need to build different multiple processes. This process could be shared across by multiple processes. So we just need to build one process, and then could be shared. And in the output, what we need to do is like depends on the user case, right? Even when they're consuming the same events, maybe different user cases requires different outputs. So that's something we can define here. Yeah. Yeah. So, and also I'm talking a little bit more about the monitoring and alerting. I mean, so one thing is like Samsung already, provides really, rich functionalities, in terms of monitoring and also alerting. So this is something is you can leverage this dashboard and to to do lots of things. And but I other than that, we also build our customized metrics. So Alan, could we go to the next one? Yeah, so we so because of now currently we have multiple use cases onboarded to our platform. So and with the platform is getting more and more complex, it's hard. It's hard to do debugging, right? So when something happens, also like I said, we see the performance drops for this whole system. We don't know which actually exactly process caused this performance issue. But after we have this customized metrics, we know exactly for each process, each user case, the performance of them, right? So once we have those numbers, we're able to really locate it, the root cause of those issues. And also once we have those numbers, it also helps us to improve our platform. We know exactly the bottlenecks of our platform. So yeah, so here's also is like the flow level metrics. So it's like we have that's the lowest level. And also next slide. And then also we have a process level metrics. So the whole process, how it performs, and also the QPS and everything, all the things we need to know about them. And also, we have a application levels metrics for the whole user case. So right, so whole user case, how the resource, it consumes, and also the performance of the whole user case. And other than that, we also built dedicated dashboard for each user case, and also we set up alerting to help us to better monitoring our the job overall. So Alan, let's go next. Yeah, so here's we enjoy using Samsung and Beam, so and also it helps us actually to reduce our development work, actually also minimize operation work. But from time to time, we have been facing quite some challenges. Scalability is one of the big one. So currently we have onboarded 5+ user cases. 18 processes, and the overall QPS. Really QPS is is over 3 million. So and also with more and more user cases, we foresee they will be onboarded to Kronos. We foresee we definitely will run into more issues. So that's why one of our current priorities to actually to support the multi-cluster for client isolation, so physical isolation. So we'll make so we want our platform to support like each user case could have their own cluster, and so this way we can separate separate one user case from another one. So it means like if one user case is down, this will not impact the other ones. So, and this will improve the overall performance of our platform and also the stability. So yeah, I think so that's all for me. Thanks everyone for listening, and now it's the Q&A time.
Thank you for that presentation.
Mm-hmm.
Yes, we have a question in the Q&A, which I'll read out. Yunwen Zhu said, how do you determine a user is a real bot or not after your system processed it as a bot?
Yeah, thanks. I think this is really interesting question. That's why we are trying so hard to build a bunch of sophisticated service and with more and more technology integrated. I'm sorry, I don't think I'm allowed to give you too much details due to their credential. But I can assure you that we we use a bunch of different sources, including the LinkedIn in-house build and third-party partners as well. to help us like get as many features as possible to help to make sure that this is the real situation. And I think I can give you another example. Is like based on our experience with Google and Microsoft Bing. I think the overall our like detection system is giving the right answer. And another example is like we have seen so many scripting attacks that they are pretending they are from Google, they are from Bing, and we with a short period of time we identify them successfully and like block and stop them like with like great results. That those examples that I can show you is 100% true. So, but I don't think I can give you more details about that due to the credential limitations.
Excellent, thank you. Next question we have, it looks like, oh, maybe it got answered. Xixing may have answered it live. Question from Wei Song about the, Xixing, can you tell me what it's, oh, I guess I can go to the answered section here. I'll just so we'll have it live here.
Yeah. So the question is how much resource, we are committed to support the overall 3 million QPS. So currently our job is deployed in multiple fabrics. So each fabric is there about 1,000 containers. So for the memory consumption for each in each fabric is about 2 to 4 terabytes actually.
Thank you.
Mm-hmm.
I have another question here from Yipan asking, can you define what the multi-cluster means? Just different Beam SAMZA jobs or physical nodes as the cluster, i.e. separate node pools in Yarn?
So yeah, this physical nodes. Yes, yes, exactly. Physical nodes as the clusters. Yeah, that's what it means. Yeah.
Thank you.
Mm.
We have a question from Ogden. I might be wrong, but I haven't seen a SAMZA release in a while. Do you have any concerns about the future of SAMZA development? So I might take this one. There are SAMZA releases coming out. I think the open source page isn't very as well maintained as it should be, but there is SAMZA still under active development. All right, I think we've answered all the questions. Let me know if there's any other questions. I think that might be it. All right, well, I guess I would like to say thank you to all of our presenters and for everyone that joined our meetup. I think FA said this right at the beginning, but this is a common question we get. We will post the video from this in a few days. We'll post it on Meetup and on Lincoln Engineering's YouTube channel. We're planning our next meetup in January 2023. If you have ideas for other talks, please reach out to FA, Gary, or myself, and we'll be like to consider any ideas you have for future talks. I think that's it. Thank you very much, everyone. Hope to see you again.
Yeah, thank you everyone for joining. Thank you.
Thanks.
Right.